Hello, Dasha.
Hi, sir.
How are you?
I'm fine, sir. What about you?
I'm good. I was expecting different students. I think again I'm with you. Maybe secondary Franz Archels is he also a student? Mr. Franz, are you a student or a teacher here?
A student.
Okay, okay. Good to see you then here. All right. Okay then, guys, good to see you. We actually start another topic here. We will talk about trigonometry today and the next upcoming 3 Sundays. Okay, 3 lessons will be about the topics and practicing some questions, and the last class will be solving problems from the test paper. Okay, this is how we are going to cover this topic. As you know, this trigonometry, right? It's one of the most important concept in math, and every engineering field that will make use of this concept, because without this we cannot actually solve a lot of problems. These are very simple relationships between the sides of a triangle, let's say right angle triangle, but their application is enormous, is huge, and especially physics, astronomy, even biology, like for example the heart beating rate, and to express any periodic functions, and they have a very, very important, how to say, contribution. So trigonometry is a branch of mathematics that deals with triangles, particularly right angle triangles. And we can just say that, as the name suggests, right? Tri means it is 3. It's a Greek word. Gon means it's a side, and the metre means I measure. So if you just translate this into English, that means that I measure the sides of a triangle. But here, basically, we'll talk about the right angle triangle. Right angle triangle is also a triangle. That's why in general we can just use triangle. But actually here we define this trigonometric relations with, what is it, in right angle triangle. So trigonometry deals with relationships between the sides and the angles of triangles, and with the trigonometric functions which describe those relationships. So trigonometry has applications in both pure mathematics and in applied mathematics. Applied mathematics means that actually anything, any other field of science, they use math. For example, biology, they use math in solving some problems, and chemistry to solve actual reactions, actually they also use math. Physics, of course, I mean, you cannot imagine physics without math. And astronomy and some other statistics or business or what is it, finance, they all use this trigonometry. Okay, so now let's just start this our trigonometry ratios in right angle triangle. All right, so actually this comes actually in the previous lessons we talked about similar triangles, right? Similar triangles means that if 2 triangles are similar, which means that their corresponding angles are equal, that means that their corresponding sides must be proportional. Okay, that means if I just give you one simple example, suppose that we are given 2 similar triangles, this triangle and let's say this triangle. Okay, suppose that they are similar. Similar means that, let's say this 90 degrees, also this must be 90 degrees. Suppose that this alpha is, the angle is alpha, and also this angle is alpha. Okay, proportional means that if this side is A and this one is B and this part is C. And here we have, let's say A1 and this one is B1. Okay, here we have B1 and here we have C1. And here we are saying that, okay, since they are similar and this is true, what is it? It is A1 over A is equal to B1 over B is equal to C1 over C. Okay, and regardless of the size of these 2 triangles, if they are similar, this relationship is always true. That means that this proportion is always true. Okay, actually the trigonometry simply, they have very close relationship. Even we can just say that the trigonometry ratio comes from here. Okay, now instead of this thing, for example, let's say, since also I can write here a over a1, right? And also actually this is true. For example, instead of this, from this proportion, also I can get this thing. For example, a over b is equal to a1 over b1. Or also I can just write this one, a over c is equal to a1 over c1. And also these relationships are true, okay? And that's why instead of writing this one, now we are going to give a special name to these ratios. And you will see that as long as you just keep this angle the same in right angle triangle, this ratio a over c, it remains unchanged. And since it is so, we are going to give a special name. What is it? We call this actually sine or cosine or tangent. Anyway, so now let's start with defining these functions. When we just said trigonometry, we have two basic functions. In general, we have six, but actually all are just derivatives of these two basic functions. Number one is the most basic function here is, what is it? It is sine function, okay? And after the second one is cosine function. And using sine and cosine, actually, we can define the tangent function. Of course, definition is different, but after all, tangent is defined maybe differently, but tangent is sine over cosine. So suppose that we are given a right angle triangle, as you see in the figure, okay? And suppose that this angle is theta, okay, theta, and this angle is 90 degrees. So with respect to this theta and this side, let me just write here, this one maybe, this one is, let's say this A, and this one is B, and this one is C. Or because it's hypotenuse, I can just write here, this one is B, and this one is C, okay? So with respect to this theta, okay, we are just going to give special name because we are going to use this frequently. That's why we have to attach a special name. When I just say that adjacent side or hypotenuse or opposite side, you should understand what we mean by this. So if you are talking about this angle, angle A or angle theta, right? And with respect to this angle theta, this BC, actually we call this opposite side because that side is faced by this angle theta, right? That's why it's called opposite side. And how about this AB? It is just sharing, right? It's one hand on one arm of this angle. That's why it's called adjacent side. And the longest side in any right angle triangle, the longest side is that, since here the biggest angle is right angle, that's why the longest side should be faced by the right angle. So the longest side is called hypotenuse, okay? So now for an acute angle, because all angles are acute angle, just angle B is 90 degrees, but theta and also this angle, they are acute angles. That means that they are less than 90 degrees. This is just introduction to trigonometry. That's why we're just going to talk about some basic stuff here, because in general, we actually define the sine, cosine, or tangent functions in a unit circle. Unit circle means that for any angle, not only for acute angles, any angle is maybe 100 or 200 or 1000 or 1 million. Okay, we can just define the sine, cosine, tangent function for any angle. But here, just introducing you to trigonometry. That's why we are going to talk about some basic fundamental stuff here. Anyway, so the sine of theta is defined as, just define this ratio, right? As long as you actually make some similar triangles to this ABC, these ratios actually opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent side, right? Actually, these ratios remain unchanged. That's why actually they deserve to have some special name. So this sine of theta is defined as opposite side over hypotenuse. Okay, this ratio, we are just giving a special name because as long as you keep this angle the same, this ratio is always the same, regardless of the size of this triangle. But if you change this theta, this angle, at the time also this ratio changes. And since keeping this theta and this angle B and angle C, right, the same, if you make any new triangle, it may be very huge triangle, but this ratio remains unchanged. That's why actually these are very important things in terms of dealing with the distance between two things. For example, the distance between the Earth and the Sun, for example. How do you calculate this? Without help of this trigonometric functions, it will be very hard, even impossible. And using the similarity, they find the distance between the Earth or between two planets or between any two points. So let's continue. How about cosine of theta? Cosine of theta is defined as adjacent side to this theta, that's adjacent side over hypotenuse. And tangent of theta is defined as opposite side, this opposite side over adjacent side. And immediately from here, we know that in the right angle triangle, if I just name, suppose that this opposite side, let me use different color here, maybe purple. Opposite side, let's say it is A. Adjacent side, let's say it is B. Hypotenuse, it is C. And also by Pythagorean theorem, right? Also we have this relationship, A squared and plus B squared is always equal to C squared in a right angle triangle. Now also from here, since hypotenuse C is the longest side, right? A is less than C. And also B is less than C. So that means that now if you just find sine of theta, what is sine of theta? Sine of theta is equal to, sine of theta is equal to opposite side, that is A over C. And since in a right angle triangle, if theta is between 0 and 90, it's always less than 1 because A is less than C. Why? It's a fraction. It's a proper fraction because numerator is less than denominator. Also the same thing here. How about cosine of theta? Cosine of theta is adjacent side over hypotenuse is also always less than 1. And also they cannot be actually less than -1. It's always between -1 and 1. But for acute angles, sine and cosine, their value is always between 0 and 1. And how about if it is 0? If it is 0 means that the length of A is equal to 0. So sine of 0 degrees, right, is equal to 0. And how about cosine? Cosine of 0 degrees, that's equal to 1. All right, actually, this is just, we have to accept this. And soon we will talk about some special angles. At that time, one more time, I will show this. This is a definition of these three basic fundamental trigonometric functions, okay? And that's it, actually. As you see here, we are talking about only two things, especially sine and cosine. But once again, they have huge application. You're going to see them a lot from now on. If you go to grade 10 or 11 or 12, if you go to a college or if you go to a university, you will see that every time you will actually see these two guys. For some special angles, accurate values of trigonometric functions are easy to be given. And accurate values means that actually they are rational numbers, but most of the values of the trigonometric functions, they are not rational. But of course, also they are not rational number because square root of 3/2 is not rational number, it's irrational number. At least you can write this in this form. Also some other things we can express, but they are not like this. And maybe it is some kind of decimal point or very, it involves a lot of roots. So here ratio sine of theta at 0 is equal to 0. Cosine of theta at 0 is equal to 1, and tangent of theta, when it is 0, 0/1, that's equal to 0. Because tangent of theta is defined as sine over cosine because of the ratio. And how about sine of 30? That's equal to 1/2. Cosine of 30 square root of 3/2. And it is this. Okay, so now the proof is, let me just show you only one proof here. For example, you may wonder why sine of 30 is equal to 1/2 and cosine of 30 is equal to square root of 3/10. So now after using, defining this, for example, how do we prove that? The first part, let me draw an equilateral triangle. Okay, if you draw an equilateral triangle, all sides are equal. This side equals this side equals this side. And suppose that one side is equal to actually 1. Here, let's say this 1 and 1 and 1. In general, you can just take it as A. It doesn't matter. And after all, we are talking about the ratio. So this A's will be gone. Now, from this vertex, right, if you just drop a height to the third side, okay, since it's a right angle, equilateral triangle, this angle is 60. And also this angle is 60. At the time, this angle will be 30, right? And so, and since in an equilateral triangle, it bisects the third side. It means that the length of this part, it is 1/2. The length of this part also it is 1/2. Now, using Pythagoras theorem, I can determine the value of this height h. What is h? H squared plus 1/2 squared. That's equal to 1 squared. Now, from here, what is h? If we just solve this for h, 1 minus 1 over 4, it is 3 over 4. Take square root of both sides. At this time, we will have square root of 3 over 2. So that's h. Now, using the definition now, I can just write sine of 30. What is sine of 30? Sine of 30 is equal to opposite side over hypotenuse. Opposite side is 1 over 2 over 1, so I don't have to write 1. So that's equal to 1. And how about cosine of 30? Cosine of 30 is adjacent side, right? It's h over hypotenuse. And what is the adjacent side? It is square root of 3 over 2 over 1. That's why we don't have to write this hypotenuse. In similar way, now I can define what is it? The sine of 60. What is sine of 60? Sine of 60 is equal to adjacent opposite side over hypotenuse. Opposite side, right, is h, so that is square root of 3 over 2. And how about cosine of 30? That's equal to 1 over 2. Cosine of 30 means, what is it? Sorry, not cosine of 30, cosine of 60. Cosine of 60 is equal to adjacent side, that's 1 over 2 over. And we know that also from geometry, if the sum of two angles is 90 degrees, they are called complementary angles, right? So here 30 and 60 complementary angles. That's why sine of 30, see here sine of 30 is equal to cosine of 60, because 30 plus 60 is 90 degrees. And from here, cosine of 30 is equal to sine of 60, right? Because of this relationship here. Here, for example, what is sine of, actually, if I just write here theta, let's say this angle is beta. What is sine of beta? It is b over c, which is cosine of theta. Okay. And how about this 45? And actually, 45 also using the similar thing, like, for example, let's say if you draw for 45 degrees a right angle triangle, right? Let's say it's isosceles right angle triangle. That means that this angle is 45 and also this angle is 45. So this side is equal to this side. And suppose that again, this hypotenuse is equal to 1, okay? And let's say this A. And what will be A here then? A squared plus A squared is equal to 1 squared. Now from here, 2A squared, right? What is A? A will be equal to 1 over square root of 2. Now from here, what is sine of 45? Sine of 45 is equal to A over 1. That's A. What is A? 1 over square root of 2. In similar way, also you can find cosine of 45 is equal to 1 over square root of 2. All right. Here are some, what is it? Common identities. What's wrong here? I think it should be here. Just a second. Okay, here are some common trigonometric identities. We have more identities, but for this lesson, this much is enough. Maybe later we will learn more. First, tangent of theta, as see, we have already proved that it is sine of theta over cosine of theta. Okay, and sine squared of theta plus cosine squared of theta, that's equal to 1. Again, everything actually we are just using that definition to prove everything here. If you're talking about right angle triangle, let's say this angle is right angle, we use purple here. Okay, suppose that this angle is theta. Okay, opposite side A, and this one is B, and this one is C. Right, and now from here we know that sine of theta is equal to, what is sine of theta? A over C. And cosine of theta, that's equal to B over C. And what is tangent of theta? Tangent of theta is B over C. I can write it as B, actually B over A. I can write it as B over C over A over C. And what is B over C? B over C is it's A over C, right? It's opposite sides. So that is A over B. That's equal to A over C over B over C. And A over C equals sine of theta, and B over C equals cosine of theta. And also from here, we know that if you just calculate this, the second one, this one is first one, and this one is second one, for example, sine squared of theta plus cosine squared of theta. Right, the second one, if we have sine squared of theta plus cosine squared of theta. That's equal to 1. Why? What is sine squared of theta? It is A over C squared. And plus cosine squared of theta, that is B over C squared. The common denominator is C squared. In the numerator, we have A squared plus B squared. And using Pythagorean theorem, we know that A squared plus B squared equals C squared. So that's equal to always 1. Now, if this angle theta is a right angle triangle, what is this angle? Then this angle will be 90 minus theta, because they are complementary angles. Now, from here, what is sine of 90 minus theta? It is opposite side, B over C, which is cosine of theta. And however, cosine of 90 minus theta, it is adjacent side, A over C, which is equal to sine of theta. Okay, these are the proof of these identities. Now let's solve a few examples. Franz, where are you from?
From the Philippines.
From Philippines, I see. Which city?
Davao City.
Okay. All right, now let's continue. One example. Solution. Given that cosine of theta equals 3 over 5, and angle theta is between 0 and 90 degrees, not inclusive. Find the values of sine of theta and tangent of theta. To do this one, always we need to draw, what is it? A reference triangle, right? So here, if I draw our reference triangle, suppose that is our reference triangle, okay? And this one is 90 degrees. And cosine of theta means that if this angle is theta, right, it is adjacent side over hypotenuse. So this side should be 3 and hypotenuse should be 5. It's not 4, it is 5. So now let's say it is x, right? And first step, using Pythagoras theorem, we can determine the value of x. Here we have x squared plus 3 squared is equal to 5 squared. Now from here, what is x? X equals 25 minus 9, 16. Square root of 16 is 4. So x equals 4. And the second one is, now what is sine of theta? Sine of theta is equal to opposite side over adjacent side. What is opposite side? It is 4. So that is 4 over 5. And how about tangent of theta? Tangent of theta is opposite side over adjacent side. So opposite side is 4. And adjacent side, right, is touching the angle, that is 3. So these are the values of sine of theta and the tangent of theta. Another question, evaluate sine of 36 times cosine of 54 plus sine of 54 times cosine of 36. Okay, so if you notice here, if these angles are different at the time, this question will be more difficult. At the time, we have to use some different techniques. But here we have 36 plus 54 is equal to 90 degrees. And we can actually do something here. So that is, since 36 degrees plus 54 degrees, that's equal to 90 degrees. Now, if you draw our reference triangle here, okay, it's not drawn to scale. Suppose that this angle is 36 and this angle is 54. And suppose that this side is A and this one is B, and this one is C, right? I don't know the values of A, B, C. Now from here, what is sine of 36? Sine of 36 is equal to A over C, right? And how about cosine of 54? Cosine of 54 is equal to adjacent side over hypotenuse, that is A over C. Now, in a similar way, what is sine of 54? Sine of 54 is equal to opposite side over hypotenuse, that is B over C. And how about cosine of 54? That's equal to adjacent side A over hypotenuse, that is C. So now, if I substitute there, suppose that that thing is equal to A. What is sine of 36? A over C. And cosine of 54, that is A over C. Plus sine of 54, that is B over C. And cosine of 36.
I think you.
No, here we have
Yes,
cosine
that's
54, cosine 36, right?
Yeah.
So cosine of 36 is B over C. So that is B over C. Now, if you simplify this, they have already common denominator, C squared. Here we have A squared plus B squared. And also by Pythagoras theorem, A squared plus B squared is equal to C squared. So that's equal to 1. Okay, next question, simplify. Sine cube of theta plus cosine cube of theta times tangent of theta over sine of theta times cosine of theta. Just we have to simplify. And just we are going to use here that suppose that again, let's say it is capital A. So solution, so this capital A is equal to, here we have sine of cube of theta or sine of theta cube plus cosine of theta cube. But instead of this tangent of theta, we can just write that identity that's equal to sine of theta over cosine of theta. And over, that's equal to sine of theta times cosine of theta, which is equal to, now this one cosine, they cancel each other, right? Here we have cosine squared and sine theta. Let me just factor out sine of theta. If you factor out sine of theta, here we have sine squared of theta, plus here we have cosine squared of theta. And over, here we have sine of theta times cosine of theta. So this sine of theta, they are gone. And sine squared of theta plus cosine squared of theta is equal to 1. So that's equal to 1 over cosine of theta. That's the simplest form of this expression. And simplifying is very important in solving equations, because if you do not first simplify and solve this, it gets very complicated. Usually in solving trigonometric equations, first we have to simplify as much as possible. Then we try to factorize it, then try to solve it. Okay, 1 minute break, guys. All right, let's continue. Another question, that's prove that sine of a plus cosine of a squared plus sine of a minus cosine of a squared is equal to 2. And for every angle, it must be true. But here, suppose that A is an acute angle. But actually, it doesn't have to be. But usually proving identities, right? How do you prove this? we have to first show that left-hand side is equal to right-hand side. So that I have to simplify left-hand side so that it will give us right-hand side. So let me just start from left-hand side. So that's equal to, immediately let's expand them. Okay, here we have sine squared of A plus 2 times sine of A times cosine of A plus cosine square root of A plus, expand the second expression. Here we have sine square root of A minus 2 times sine of A times cosine of A plus cosine square root of A. So now if you add them, right? So here this minus sine 2 times sine of A minus 2 times sine of A, they are gone. And here we have sine squared of A, sine squared of A plus cosine squared of A, cosine squared of A. So now here we have to just factor out 2 inside the parentheses. Here we have sine squared of A plus cosine squared of A. And we know that this actually is equal to always 1. So that's equal to 2, which is equal to right-hand side. So the proof is complete. Another example, given that sine of theta times cosine of theta is equal to 2 over 5, and the angle theta is between 0 and 90. The question is, find the value of tangent of theta. Okay, so how do we do that from here? Solution. All right. Suppose that here we are given right angle triangle, okay, and this angle is theta. All right, and suppose that this side is A and this side is B and this side is C. Okay, now from here sine of theta is equal to A over C, and cosine of theta that's equal to B over C, right? And what is given here? The your product is given, right? That is A over C times B over C, that's equal to 2 over 5. Now from here, I can just write here A times B is equal to 2 over 5 times C squared. Okay, so what we have to find here is we need to find tangent of theta. Let me just write here tangent of theta. Tangent of theta is equal to B over A. Okay, so how can we get actually B over A from this relationship? All right, instead of B over A, right? So I have to express everything in terms of maybe A. At the time, we can just write this. All right, so now from here, also we know that A squared plus B squared is equal to C squared, right? So now instead of this C squared, I can just write 5 over 2 AB. And if I divide both sides by, okay. All right, instead of the C squared, what is C squared? It is 5. Actually, I can just write it A squared plus B squared is equal to, what is C squared? That is 5 over 2 times A times B, right? So now from here, I can just actually divide both sides by AB. So here we have A squared plus B squared over AB. Or I can just write it as, if you separate this and write it as a sum of two fractions, A cancel each other, A over B plus B over A. On the right-hand side, we have 5 over 2. Okay, so what is A over B then? A over B should be equal to 2. B over A, it should be half. Or A over B half and B over B is equal to 2, right? So now from here, So it says, okay, 90 degrees. We have two possible answers here because you can just try to take it as x, 1 over x. We can solve this, but here we will have two possible answers. Here we have a over b is equal to 2, or a over b, or let me just write here, it's b over a, right? It doesn't matter here. Okay, b over a is equal to 1 over 2, or b over a is equal to 2. Okay. So given the find the value of tangent of theta, so tangent of theta is b over a, that's equal to 1 over 2 or 2. What do you think, Dashel? Which one should we pick? Both answers or only one of them?
I think both, sir.
Because of sine of theta, cosine of theta, right? It is, if a is equal to, for example, okay, the first one is b equals, a equals 2b. If it's 2b, yeah, we'll get the same thing. That's why we have two possible answers. So that's why dot, 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 tangent of theta is equal to 1 over 2 or 2. It has two possible answers depending on the value of theta. All right, next question. In an isosceles triangle ABC, AB is equal to AC. Okay, if the altitude AD is twice of the altitude BE, find the tangent value of the base angle. Okay, it says that, let me just draw those things, and after that, we'll just see. So this altitudes, or altitudes, and also altitude from here. Okay, these are the altitudes, right? So it says that BE. Okay, this one is C. Actually, this should be, this point is, it is D. And this point is, it is E. And this is an altitude, and also this one is an altitude. Okay. And suppose that in an isosceles triangle ABC, AB equals AC. Suppose that AB, AC is equal to A. And the third side, it is C. So since it is isosceles triangle, so this side should be equal to C over 2. And also this side should be equal to C over 2. Okay, it's not an equalated triangle, it's just isosceles triangle. Now from here, solution. So the question is here, we need to find tangent of alpha, right? What is tangent of alpha? We're going to find this. So first, okay, AC is equal to 2 times BE, right? From here, what is tangent of alpha? It is opposite sides over adjacent side. It is opposite side, okay, BE times EC, tangent of alpha. How about in the big one? Tangent of alpha is, it is AC over CD. Okay. All right. Let me just do something here. Let's say AD is equal to H. At the time BE it says AD is twice of the altitude BE, so it must be H over 2. Okay, so now from here, we can just write, what is it? The relationship here. So what is tangent of alpha? In the big triangle, tangent of alpha is equal to AD, opposite side, that is AD over DC. And what is AD? AD is equal to H. And DC is equal to C over 2. Or simply, that's equal to 2 times H over C. How about in the small triangle, triangle EBC, right? Also, tangent of alpha is equal to opposite side, that is BE over, right, BE over BC. That's equal to, what is BE? BE is H over 2. H over 2. Let me just write as division. BC is equal to C. So that's equal to H over 2 times C. Okay, so these things are the same, right? Actually, 2H over C equals H over C over 2. Did I make a mistake here? BE H over 2. No. BE, it is H over 2 divided by BC. No, EC, right? Adjacent side, EC. EC. What is EC? Suppose that EC is equal to X. Okay, so let's say this X, so that's equal to H over 2X. So now from here, if I know X, we can find tangent of alpha, right? Because I have to cancel these things, and I need to know what is H over C. Now from here also, using Pythagoras theorem, BE squared, that is H over 2 squared, plus X squared should be equal to C squared. Now from here, what is X squared? X squared equals C squared minus H squared over 4. Okay, and also from these two things are equal, right? 2H over C is equal to H over 2X. So this H cancels each other. From here, X is equal to C over 4. Okay, so I can find the relationship from here. Now from here then, let me change the color. So instead of X squared, I can write C squared over 16 equals C squared minus H squared over 4. If you multiply both sides by 16, and here we have C squared equals 16 C squared minus 4H squared. Now, what is H squared then? H squared will be equal to, and take 4H to the left, C squared to the right, 15 C squared. So that is 15 over 4 C squared. Okay, so unfortunately it's a bit messy now. So H is equal to square root of 15 over 2C. Okay, so guys, let me just write a final answer here. Okay, now if I just write this one, from here I can write H over C. H over C is equal to square root of 15 over 2. So now from here, then we can write our answer, dot, tangent of alpha is equal to 2 times H over C, right? 2 times H over C. H over C is equal to square root of 15 over 2. That's equal to square root of 15. That is the answer. This is how we just do some brainstorming and mental exercise. Franz, Dashel, do you have any questions about this problem?
None,
No,
but I
sir.
am still a little confused. But I can understand it if I read it all over again.
Say again, what did you say?
I don't I am a little bit confused pa, but I can understand a bit, but I can understand it on my own.
Okay, good. Here the main idea is, okay, we are trying to form an equation. Tangent of alpha is expressed in two different ways. And as you see here, we have h over c. I'm trying to find this ratio. So this ratio, to find this one, we form the equation and using Pythagoras theorem. And as you see here, we x, right? And also I know the relationship between x and h, and just equating these two things, I can find how x is connected to c. And after we substitute, of course, you can just watching is not enough. After the class, if the question looks a little bit challenging or difficult or not clear, you have to try to solve this one more time yourself. Okay. And after that, if you get stuck, look at it again, or still you don't understand, next week you can ask, we can discuss one more time. Let's continue. Find the value of tangent of 15 without use of a calculator. How do we calculate this? Okay, let's try to do something. Let me just draw one triangle in such a way that okay. Suppose that this angle is 30. At the time, this angle will be 60. Okay. And suppose that this angle side is 1. Okay. By using, actually, if you remember, what is sine of 30? Sine of 30 is 1 over, if it is 1 over 2, right? So it must be 2 because sine of 30 is 2. How about cosine of 30? 1 over square root of 3. So this side should be square root of 3. Right? Because sine of 30 means opposite side over adjacent side. That's equal to 1 over 2. So if opposite side is 1, so hypotenuse should be 2. And using Pythagoras theorem, now we can find the third side. Square root of 3 squared plus 1 squared, that's equal to 2 squared, which is 4. Okay. So now let me just actually draw another line. Maybe I should use annotation again. The problem with the annotation when you move to the next slide and I forgot to delete it, that's what I don't like, but we have no choice. Let me just actually draw another line that is equal to the hypotenuse. Okay, let me a bit longer. Okay, and also from here, like this. Okay, suppose that this actual side is equal to this side. Sorry, is this side. Okay, if it is so, that means that this angle should be equal to this angle. And since this exterior angle of these two angles are 30, that means that this angle should be 15, and also this angle should be 15 degrees. Okay. So now the problem is, how can we find the tangent of 15? Tangent of 15 will be, what is it? Since actually this side, well, it is 2. Let me just write here, let me C, and this one is A, and this one is B, and this one is D. And AB is equal to AD, right? And what is AB? AB is equal to 2. That means that also AD, it should be equal to 2. Now from here, then what is tangent of 15? Tangent of 15 degrees will be equal to opposite side over adjacent side. What is opposite side? Opposite side is 1. Over adjacent side, it is 2 plus square root of 3. But now, if I want to rationalize the denominator, multiply numerator and denominator by 2 minus square root of 3, 2 minus square root of 3. In the numerator, here we have 2 plus square root of 3 times 2 minus square root of 3, which is equal to 2 squared 4 minus 3 is equal to 1. So the answer is 2 minus square root of 3. So the exact value of tangent of 15 is equal to 2 minus square root of 3. Okay, guys, any questions? Good, that's all for examples, just introduction. Now we are going to practice some questions in exercise 1. Okay. Evaluate. Now we have a few questions. Let's just try as much as we can. Evaluate sine of 30 over 1 plus tangent of 60 times tangent of 30. Okay. And again, just remember that solution. Remember that tangent sine of 60 is equal to cosine of 30. We have already proved this. So I try to express everything in terms of one function. And this is how you usually simplify trigonometric expressions, or even for proving this really important thing or solving equations. So sine of 60, okay, instead of sine of 60, okay, let me just write it as sine of 60 over 1 plus tangent of 60. What is tangent of 60? That is sine of 60 over cosine of 60 times tangent of 30. It is sine of, guys, I don't have to do anything. Why am I doing this? Sorry. I will just use the table, okay, to do this one. It's much better, I think. So that's equal to, suppose that that's equal to A. So this capital A is equal to, what is sine of 60? Sine of 60 is equal to 1 over square root of 3. And 1 plus, what is tangent of 60? 1 over square root of 3 over 2, right? That's equal to 2 over square root of 3 times, what is tangent of 30? It is 1 over 2 over square root of 3. That's equal to square root of 3 over 2. So now these two things are gone. So here we have 1 over square root of 3 over 1 plus 1. That's equal to 2. So that's equal to 1 over 2 square root of 3. Another example, evaluates. So just we have to evaluate them again using, what is it, those table. So A is equal to, let's say this one is equal to A. So also we can just write it as 1 minus, what is it? What is tangent of 60? We have already calculated here. Let me just one more time. Where's our table? Tangent of 60 is square root of 3. Did I write here square root of 3? Tangent of 60. That's equal to square root of 3 over 2 sine, and cosine 1 over 2. So that's equal to square root of 3. No. This one is square root of 3. Square root of 3 times tangent of 30, sine of 30, 1 over 2, and square root of 3 over 2. That is 1 over square root of 3. 1 over square root of 3. Okay, next question. So tangent square root of 60, it is square root of 3 squared. So square root of 3 squared over, what is sine of 30? 1 over 2 times cosine of 45, 1 over square root of 2 squared equals, the first parenthesis is 1 minus 3 over 1 over 2. That's equal to 6. And here we have 1 over 2. That's equal to negative 5 over 2. Okay, next question. Given that tangent of theta is equal to 1/3, and angle theta lies between 0 degrees and 90 degrees. If phi plus theta equals 90 degrees, find the value of cosine of phi. So it says that phi plus theta is equal to 90 degrees. That means that here, if we draw a right angle triangle, okay, if this angle is theta, then this should be phi, because their sum is equal to 90. And from here, tangent of theta is equal to 4/3, right? So this opposite side should be 4, and this adjacent side should be 3. And what is the hypotenuse? Using Pythagoras theorem, it should be equal to 5, because 3 squared plus 4 squared equals 5 squared. And what is the question? We need to find cosine of phi. So this cosine of phi is equal to adjacent side over hypotenuse, that is 4/5. Next question, given that tangent of theta is equal to square root of 3 and cosine of phi is equal to 1/2. Theta is between 0 and 90, phi is between 0 and 90, but we don't know how they are related to each other. So we have to find sine of phi, cosine of theta, plus tangent of phi, sine of theta. That means that as a reference triangle, we have to draw 2 right angle triangles. So that is our first one. And that's our second one. The first one is for theta. What is theta? Let's say this angle is theta. In our second triangle, let's say this one is phi. So since tangent of theta is equal to square root of 3, so opposite side is square root of 3, adjacent side is 1. So hypotenuse should be equal to 2. And the second one, cosine of phi is equal to 1/2. So adjacent side is 1, hypotenuse is 2, it is 4. So this should be again square root of 3. We are talking about similar, triangles. So from here then, I can just write here, what is sine of phi? Sine of phi equals square root of 3/2. And cosine of theta, it is 1/2 plus tangent of phi. Tangent of phi is square root of 3/1. That is square root of 3. And how about sine of theta? Sine of theta is the first one, right? Opposite side, square root of 3/2, which is equal to square root of 3/4 plus it is 3 multiplied by 2, it is 6/4. So that is 6 plus square root of 3/4. That is the exact value of this. All right. Next question. Given sine of theta is equal to 0.8 and the angle theta is between 0 and 90 degrees, find the values of cosine of theta and tangent of theta. Okay, these are also easy questions. Immediately we have to draw, since angle theta is acute angle, and suppose that there's a theta. And sine of theta 0.8 means that's what is 0.8? 0.8 is 8/10. Or by 2, it is 4/5. So opposite side, it is 4. Hypotenuse, it is 5. So the third side should be equal to 3 by Pythagoras theorem. Now from here, cosine of theta is equal to adjacent side over hypotenuse, that is 3/5. And how about tangent of theta? Tangent of theta is equal to 4/3. Okay, another question, similar question, but let's do this quickly. Tangent of theta is given, that is 2/4. Now let me just write it as a fraction. So 2.4 is equal to 24/10. Or if you divide both numerator and denominator by 2, it is 12/5. So if this angle is theta, opposite side should be 12 and adjacent side is 5. And 5 squared plus 12 squared equals, what is it? 169. And 169 is a square number, its square root is 13. Now from here, sine of theta, is equal to 12 over 13. And cosine of theta is equal to 5 over 13. All right, next question, question 7. Given that sine of theta is equal to 5 over 13 and angle theta is between 0 and 90 degrees, evaluate 3 times tangent of theta minus 1 over cosine of theta. Again, it's just, these examples are just warm-up examples, I think. Suppose that this angle is theta, opposite side, right? It is 5, hypotenuse, it is 13. So this side then should be equal to 12. Now from here, what is tangent of theta? Tangent of theta is equal to 5 over 12. And how about cosine of theta? It is 12 over 13. So let's say our expression is A is equal to 3 times tangent of theta, that is 5 over 12, minus 1 over cosine of theta, that's equal to 13 over 12. And 3 times 5 is 15. 15 minus 13 is 2 over 12, or that's equal to 1 over 6. Question 8. Sine of theta is equal to 3 times cosine of theta, and angle theta is between 0 and 90 degrees. Okay, evaluate sine of theta times cosine of theta. Again, from this, as you see here, if I just divide both sides by cosine of theta, because angle theta is between 0 and 90, not inclusive, which means that cosine of theta is not equal to 0. Now, from here, sine of theta over cosine of theta, that's equal to 3. And what is sine of theta over cosine of theta? That is tangent of theta. Tangent of theta is equal to 3. So now if we draw our reference triangle here, 90 degrees, suppose that this angle is theta, and this should be 3, and this should be 1. And 3 squared plus 1 squared is 10, so the hypotenuse is equal to square root of 10. So now from here, sine of theta times cosine of theta is equal to sine of theta, 3 over square root of 10. And cosine of theta, 1 over square root of 10, which is equal to 3 over 10. Franz and Dasha, I'm going a bit fast because these questions are very standard questions. Is everything clear?
Yes, sir.
Yes.
Good. We have 5 minutes. Let's continue. Try to solve a few more questions and finish the class. Evaluates sine of 27 cosine of 63 plus sine of 63 cosine of 27 without using a calculator. Again, once again, we know that if alpha and beta are complementary angles, that means that if alpha plus beta is equal to 90 degrees, we have already proved that cosine of alpha is equal to sine of beta. So that means that from here, sine of 27, what is cosine of 63? That's equal to sine of 27. Plus, here we have sine of 63, that is cosine of 27 and cosine of 27. So now here we have sine squared 27 degrees plus cosine squared 27 degrees. And if these angles are equal and they are squared, they're always equal to 1. Evaluate without using a calculator. So sine 43, tangent 47, and cosine 43. So equals first sine of 43 times what is tangent of 47? That is sine of 47 over cosine of 47. Minus, here we have cosine of 43 degrees squared. Now I try to express everything in terms of one angle if possible. Now from here, sine 43 times, what is sine of 47? It is cosine of 43. And how about cosine of 47? It is sine of 43 because 47 and 43, they are complementary angles. Minus cosine of 43 degrees squared. So now these two guys are gone, right? And cosine 43 minus cosine 43, that's equal to 0. So the answer is 0. Okay, simplify the following. Let's just do a few of them and move to the next question. And tangent of theta times cosine of theta. Tangent is sine over cosine, right? So that is sine of theta over cosine of theta times cosine of theta, which is equal to sine of theta. And also the b equals, here we have sine square root of theta. What is tangent? It is sine of theta over cosine of theta times cosine of theta. And this cosine, they are gone. Sine squared over sine, that's equal to, again, sine of theta. And how about in 4? For C, 4 times sine of theta minus cosine of theta times tangent of theta is sine of theta over cosine of theta. So this cosine cancel each other. 4 times sine of theta minus 1 sine of theta, that's equal to 3 times sine of theta. Okay, let me just use all right. Yeah, it will continue. We have a lot of problems here. I don't know what to say. Anyway, France, Dachel, we've started a bit late today, 5 minutes. It's okay. I don't want to take your time. Okay, it's a scheduled time. Thank you very much, France. Nice to meet you. Okay, we will continue next week. If you have time, you can just practice the rest of the questions. If you don't understand anything during the class time, you can ask. Okay, I can just also try to explain at the same time. Guys, have a nice weekend. I will see you next week. Okay. Bye bye.
Goodbye and thank you, sir.
Bye bye.
Bye-bye.
Goodbye. Thank you.